So now we should formally try to answer what the heck is a logarithm, or what is this logarithm of which you speak, Professor Peoples, and let's try and give it a more formal definition. We stated that if we say to what power must we raise a to get x, we mean that, well, logarithm base a of x is the statement we want to make, and y, if that was our result of taking that logarithm, is the exponent. So we can actually go to our formal definition right here. And it says if we let a, which is our base, be greater than 0 and a not equal to 1. Where have we seen this before? That's right, go back to your definition of the exponential function. We're going to say that anytime we take x greater than 0, that is, if we only take positive numbers for x, then we can say y equals the logarithm base a of x, if and only if a raised to the y power equals x. Now, I'll make a quick note right here that our functions, right, the functions logarithm base a of x and a to the x are in fact inverses. I don't know if you remember anything about inverse functions, but we'll talk about them a little bit here in a while. But let's just talk about this expression, this function. We say this is called a logarithmic function with a base a. And all it really says is that f of x is always the exponent to which we must raise that base a in order to get the value x each and every time. So what does that mean? Well, we can use this definition to go between equivalent exponential and logarithmic functions of the equation. So for example, if I told you that I was going to raise the base 2 to get to the 10th power, and that gives me 1024, what does that look like in logarithmic form? Well, in logarithmic form, this is, by the definition, a to the y is equal to x. So if we shuffle around the numbers on the page just like we do right here in this definition, we should be saying then that 10 is the result of taking the logarithm with a base 2 of the number 1024. Interesting. Okay, so we're just using the definition directly. Same thing can be said right here. Even though the numbers are fractions, it doesn't matter, right? That definition still applies in exactly the same way that it did. So that 27 eighths is, oh, let's try that again, not 27 eighths, right? Because we're taking a logarithm of 27 eighths, right? Our exponent, right? This is easy to get confused. See it? A to the y is equal to x. Sometimes it helps just to write that definition next to it. A to the y is equal to x means that if we were to take the logarithm, make the base 2/3, and make the argument 27 eighths, our result should be -3. How about this one? This seems a little bit more difficult. Well, it is, except if you realize that when we say square root of 169, we have a way of rewriting that in exponential form. 169 raised to the 1/2 power is going to give me 13. So my base is 169, my power is 1/2, and 13 is the result. So by this definition, we should be able to say that 1/2 is the result of taking a logarithm with a base of 169 and making the argument 13. Notice, by the way, that the base is always written as a small number in logarithmic form, and the exponent, the argument right here, the result of raising 169 to that power, is always written normal size, right? It's not an exponent, it's not anything else, it's just log subscript 169 of normal size 13. All right, how about these ones down here? Let's say we wanted to rewrite each logarithmic equation in an exponential form. How would that work? Well, same deal. Remember, we said that y equals logarithm base a of x if and only if a to the y equals x. This is a relationship that works both ways. When we see the words if and only if, logically that means one always implies the other. So this base 4 would be raised to the exponent 4. And the result of that is going to give me 256. So in other words, the exponential equivalent expression is to say 256 is the same as 4 raised to the 4th power here. Here's another one. We say, well, logarithm, the base is 5, the exponent is negative 3, and the result is 1 over 125. So we could say then that 5 raised to the negative third power should equal 1 over 125, which it does. We recognize our rules about exponents. Negative exponents means takes 1 over that base to the positive exponent. Here's another one. Logarithm base 9 of 3 equals 1/2. Well, that's similar to the expression above it, right? The base 9, when raised to the power 1/2, gives the result of 3. So we could write that 3 is the result of taking 9 raised to the exponent 1/2, which, by the way, is the same thing as the square root of 9. More to come.